Yeah, I'm always ready.
Good evening, ladies and gentlemen, and welcome to Faculty of Architecture at Chulalongkorn University. Tonight is a very special event, part of the lecture series, Architecture and Design for Society, which are being hosted on behalf of the faculty this year as part of their 90th birthday celebrations. So thank you to the Dean for organising all of this. I think we have a word from our sponsor, Support Thai. So thank you, Dan, for organising this event. My name is Scott Drake. I'm Deputy Director at INDA. So I see a lot of young school age guests in the audience. I'm hoping it's because you're interested in coming to study in the faculty. So if you would like to come and study in the Thai program, I'm sure that we have many instructors here who can talk to you. If you would like to study at INDA, come see me. If you would like to talk to some of our graduates, we have some of our graduates here who are here with their boss, who's a prominent architect working here in Thailand. So a lot of connections for you. Feel free to say hello. We can give you a card and tell you about the application process. So pleased to see you here. I'm not sure why you're here or how you knew about it. Perhaps you're studying Kas as part of your Year 12 studies or something similar. But anyway, we're very pleased this year to have invited Kas Oosterhius to INDA as a visiting professor for the 23 to 24 academic year. I put out a call to various friends on Facebook around the world, and Kas applied and said he'd love to come and visit Bangkok for a year. So he's come to join us, and his wife Elena Leonard is with us as well, who's a wonderful practicing artist. So I hope you are familiar with their works and have a look a little bit deeper. So we're very pleased to have Kas here. He's working in a design studio. He's brought a lifetime of expertise with him. So he's a practicing architect from the Netherlands. I won't say how old, but he's had many successful projects. He's one of the pioneers of, I'm not sure how to say it, but parametric architecture or organic architecture, or there's 10 different ways of describing it, and none of them are accurate. So really one of the great pioneers of architecture in the 20th century, 21st century, and both together. An inspiration for me when I was first teaching, and so a very prominent figure throughout the world. He worked, as I said, in practice and also at TU Delft for 15 years. He spent the last few years at Qatar University, and now we're very pleased to have him here at INDA at Chulalongkorn University. So his lecture tonight, as you can see, 12 Rules for Another Normal, is referring to his book, which will be published about now. So we'll be having a book launch soon if you would like to keep in touch with what's happening. Hopefully you can get a signed copy somehow. The component personality towards another normal. The lecture series is about design and architecture for society, so a contribution to society. So Kas will talk about the various components of his book, with a focus on the contribution to society made by architecture and design. So before we start, I'd like to ask the Dean, Jan Sagyut, to come up and be a obligatory photograph and gift and say a few words. Thank you.
Because I don't think you want to listen to me. Welcome everyone to the Faculty of Architecture at Chulalongkorn University. We also thank you for Mr. Kas to having us a lecture today. I think it's very interesting that you can see a lot of his experience of working on architecture and also his teaching, not only working as an architect and also teaching. So welcome, Kas. Thank you very much for having us today.
Thank you. Thank you. Take a picture. Okay.
Is there an obligatory photo?
How about taking a picture up there to see the audience?
Yeah.
Yes, please.
Everyone in the back.
Okay. Yes.
And this.
A little key from us. Very little.
Good.
Okay. 1, 2,
3, 4.
1, 2. Thank you.
You were there.
Yeah, I'm in it.
Oh, you're on the photo. Or? 17. Yeah. Okay, thank you both for the generous introduction. I will try to live up to some expectations. My societal commitment is maybe not that big, but I will try to build relations between some of those aims, some of those goals that would actually work for another normal, for a better society, and try to build a link to the work we have done. Some of the works, it's obvious, others it's less obvious, but okay, it's some tour de force to build that bridge, but I will try to do that. So another normal, to cut it short, is just the here and now. It's not another normal that is elsewhere on another planet, it's just here and now. You may want to scan this image, then you are directly connected to my website and an interview with the publisher, River Publishers. River Publishers, this is the book. River Publishers is actually a scientific publisher, not an architectural publisher. And for them it's quite exceptional to have this in their portfolio. So let's see how it lands in the scientific world. We are often considered as architects that have this tendency to have a scientific approach, to know things exactly, not in vague illusions, not assumptions, but knowing things. That's what we have tried to do in our architecture, and that is what I tried to describe. I'm not sure where I should stand, maybe here. What I try to describe in the book, the component. The component is an essential thing, and it's especially number 5 that is crucial. It's the components versus elements. Elements, you know, Rem Koolhaas with the Biennale, elements, fundamentals. I question that deeply, if that's elemental or fundamental, what he was presenting. So it's described in there, so that is one of the crucial chapters. Then I go to the component itself, what is the situation now, and then I jump into proactive components, which relates very much to our activities at Hyperbody. Scott was referring to that. We did complex architecture and we did interactive architecture, and from interactive it's just one step to proactive. Where do we want to go? That's an open question, and I was referring to the Chinese patient, which is the last chapter, and he gave some ideas. On the basis of almost everything we do is this. So can we find a simple rule that creates diversity, that creates complexity, simply by following the rule, and don't lose yourself into exceptions to the rule. But then that rule should indeed be defined in such a way that it indeed creates diversity. What you see to the left is my first building, 1987, so it's quite a while ago. That is actually also rule-based in the age of prefabrication, of standardization of as many elements, there I probably use the word elements, as many elements as possible. So many of the same, to actually create a building which is a very low budget building with the state-of-the-art technology of that time. And then you see the other building, which is one of my latest, tower in Abu Dhabi, which is representing the idea of customization. So all of these components, now I use the word components, are all different, but they follow the same rule. They follow the same simple rule that creates that diversity. And you see the difference in appearance, and you also see that I kept being faithful to a sort of minimalism. So it's a minimal maximalism to create this diversity. You can see many other examples that create a wild diversity without being able to really control it. So I was always trying to be faithful to some rules that govern science, like, for example, cellular automata. Some rules in cellular automata create boring sameness. So, depending on the rule, cellular automata looks to its nearest neighbors and then applies the rule one by one, row by row. And some end just black or just white, others end up with creating diverse patterns. So that has been inspiration in many ways for us. Also this, when you bring it to life, when it becomes a swarm, following very simple rules, like keeping a certain distance, synchronizing the speed with your nearest neighbors, look at the direction, and of course one of the main interesting things for science is that there's no leader. If there's an external factor that brings the swarm somehow to turn away, then suddenly another bird is the leader. There is no leader, only very temporarily and very locally. So that condition we found completely inspiring and tried to find an architecture that responds to that. In Hyperbody we did many explorations, many research projects. One of these projects is this proto deck, where, and then I have, so each component is parametrically designed, but more than that, it is accepting input from people walking on that deck. It has pressure sensors, it communicates with nearest neighbors. So it's as if you are walking on a keyboard, basically. But then a smart keyboard where the keys are connected to their neighboring keys. So it follows the principle of the swarm. Also it follows the other principle of the swarm, that they respond to external factors. They are not alone, it's not an autonomous system, no, they are always swarming in an environment that has considerable impact in the way they behave. Some of the things we did in Hyperbody, and this is a slide from almost 20 years ago, I think, 15 maybe. So we dived into many subjects that are still very actual today. Even neural networks were part of the research. There is immediate architecture, interactive, there's quantum architecture, whatever that may mean. But we had very smart guys looking into that. It's actually trying to deal with unpredictability. We had interactivation, TransLab, we were connected to Marcus Novak, etc., Robotics Institute. It was all there. And we did many projects, like here, these prototyping, making things work. That was the basic thing that we said. You can do anything, but it has to work somehow. Not speculate, it has to work. So I put in this slide. Now we are here. Why don't we talk about creating a situation that can be considered a lab, where actually the smartest people work together, not only with people from the faculty, but also from innovation, etc., from other faculties. Okay, let's jump to some projects. First I show some project, and then I come to that idea of which rules would be interesting for a more fair and a just world. And technology and the application of technology in architecture is one of those rules. This is the acoustic barrier with the cockpit inserted in it. You see a very long stretch structure, 1.6 kilometer, and you see fault lines here, and I'll talk about that later. This is the structure as a whole. It's a simple 3D model, actually. It's flattened at the ends, so lifted up, almost floating, and then it's squeezed. It has two sides, two surfaces, squeezed along the stretch. It's pumped up where there is the possibility to have a building inserted in the acoustic barrier. This is how we designed it. So we modeled it and then we went through this project. One hand, sections, the other hand, the experience, the 60 seconds of architecture. What happens is that the section is never the same. So these and sections actually are not sections as such, but are cuttings of a 3D model. But what is more important, how do you realize something like this, where everything is different all the time, for a very low budget, minimal budget? We wanted to have it transparent, a bit less transparent where there is the showroom for luxury cars, but in the evening it lights up. We were told not to distract the public too much while driving the highway, so don't be too transparent. People at the other side were worried that it would reflect, but the actuality is that it reflects much less the sunlight than any other building because of the faceting and the triangulation of the building. You only have a reflection for a very short period of time. Fault lines and looking at cars is one of my main activities when I am driving the road. I'm always looking at cars. So why are cars designed as they are? One of the things that we share with the acoustic barrier is we wanted to reflect the sky in the upper part and reflect in the lower part, reflect the earth. So you had this division between lighting up and darkening, and it makes it more slender, more slim. It makes it more acceptable as a barrier. And in car design it has many other functions, and actually in the acoustic barrier as well, because it stiffens the material, so you can use less material, thinner metal or thinner plastic. This is the interior, so it's very bright in the interior. We designed it in such a way that the cars are actually lit by natural light, and only for the darker periods and the evenings the lights in the upper line, you see it integrated up there, are helping and distributing some more lights. It feels, if you're inside this building, actually it feels like a terminal, 160 meters long, 30 meters wide, and it has an endless loop for the cars. Cars can go down there, the other side they can go up again to the elevated part, go down here. So can they make a loop inside the building? What I especially liked about the lighting effect, that it also projects the structure on the cars. So it's not only the car, it's also the building that, or the car that absorbs the building in a way. And these are my friends, Antonino Saggio and Marcos Novak. And I'm still hoping for that some of these guys may be invited once, because they're geniuses of their own kind. Okay, building this is a simple procedure, a simple rule that creates this diversity of 40,000 different pieces of metal and 10,000 different pieces of glass. They're all different. So they have to produce according to a procedure, an algorithm, a process. We used scripting to get there, and we used the file to factory method to get the information from our machine to the machines of the factory. Then they would produce all these components, so I call them components, not elements, because each one is only fits in one particular place. And the workers, all they have to do is put them together in the right order. So they are not skilled workers, not at all. The only thing they have to do is read a number, and then they know. They had a little piece of paper. This number fits there, that number fits there. Simple, really simple. And it turned out to be very, very cost effective. The scripting was done in such a way that we projected 10,000 lines horizontally into the 3D model of the acoustic barrier, and then we wrote a script that asked each of those points, where are you in relation to your nearest neighbor? So here comes that swarming effect again in managing the structure, managing all the different components, and then asking to take one of those, put it down there, give the right measurements, right dimensions, and send these data to the factory, the glass factory and the steel manufacturer. So one of these rules, I call them rules, could also be said to be laws or procedures or whatever. One of these is related to this, robotic production. So I will talk more about that. I will also briefly go into the other things, and some of them are really social. But I try to discuss it in such a way that it's not just social, but techno-social. This in contrast with what is called techno-feudalism, which is big tech actually dominating everything. This is using technology to build a fair and just world. So let's see if it makes sense. If we can look at these 12 rules and then combine them and recombine them to create something that might be better. And some of it is controversial, I can tell you. Chinese patient, he had 4 points for a better world. Very simple. This was a documentary in Dutch television. He said food must be better, closer to home, transport by limousine, and he wanted China to be one big villa park. So my question is, who doesn't want this? It's so obvious, but he was actually imprisoned because of this. So you can have opinions, but you should take care of the context in which you actually propagate those opinions. So he was not a fool. Ubiquitous. I use the U in front of everything because it has to spread all over. Ubiquitous basic income. I'm not an expert here, so I'm just a bit speculating, but you need stuff for that. You need all this. You need to have a digital ID, you need to have digital wallet, because I'm talking about digital money, not paper money. And if there's a question, if there is money, I don't think that's a problem. So here comes my friend AI, Bing. I asked how much money was printed in 2020 in the USA, and that's quite a bit. 30,000 per US citizen. That is basic income, basically. It was in this context, but I think building a fair and just society is also a justifiable context. And it has a history. It has a history of great thinkers and philosophers. And he said the same. You should not have to work for having a guaranteed quality of life, basically. He also said, which I only read recently, that when education is finished, no one should be compelled to work. Meaning, also education should be free. Now, these two go together, I would say. So this guy said the same, guaranteed income. Any problem with that? Yes. The US had a big problem with that, because they think this is socialism, communism. And I think this is one of the reasons this guy was shot. Maybe not only the racial question, but also the... I have taken some inspiration from Yanis Varoufakis. I can recommend this book, and maybe some of you have read it. He describes in a science fiction manner, a science fiction novel, another society, another possible now, where actually everything is sort of okay, where people participate in companies. He says no more shareholders that are not part of the company, only shareholders that actually play a part, an active part in the company. So he says many credible things, and there's also a sort of time machine involved in this novel, quite intelligently woven together. And in the end, surprisingly, he says, maybe I prefer the messiness of today and think ahead from here. What can we do now? And not dream away in a possible future, but actually look at here and now and act here and act now. Land rights, I think, is another thing that is typically considered as a communist thing, but is it? I don't think so. Let's consider that idea that every citizen has birthright to a plot of land, which is actually the case in the United Emirates and in Qatar. The Emirati and the Qatari, they have this birthright to own a plot of land. Usually when they get married, they are offered a piece of land where they can build a house. And then have a big loan to build a house, so it comes back anyway. But you need some measures to go there. And one of the things I think is an interesting idea, which is just an idea that is around for quite a long time. Eat less meat, reduce livestock, and you can easily reduce it in half, easily, because much of the land is actually used to grow fodder, food for livestock. So agriculture and livestock is hanging together in many ways, and it's imposed upon us basically to consume. We can consume less easily. And then this is the land basically. Now in Holland it is. If I would flying over Thailand, it wouldn't be much different actually, maybe more densely populated, although Holland is one of the most populated countries in the world. This kind of land takes up more than half of the country. So we have a lot of land. We have a lot of space available for building a house, for example. So here you see agriculture and livestock. Is they still working? Yeah, and livestock on vast stretches of land. You hardly see any houses, a few farms. So yes, this could easily be done, and by a simple rule. I mean, if a government would just say, okay, we just reduce it by half in 5 years or so. You can do that. A government can do that. And they do things like this, but mostly in the reverse direction. So cows in Holland, they live in a density of 3 cows per hectare. When we built an environment for people, we built an environment with 30 houses per hectare, it's almost 100 people. So there's a factor 30 difference in inequality, I would say, how we treat cows, at least in relation to the plot of land, and how we treat people. So my point was, from my thesis project on, why don't we just switch? We do the cow part, cows do our part in the density, and then still they are quite good off. In that project, by the way, it's Ashok Balotra, who is the designer. We did two projects, one of our earliest projects, one here and one here. It was built on the theme of glass houses, so the ground floor was quite extensive piece of glass house, and we had this bar on top of it, dazzle painting. We wanted to do away with traditional elements of architecture. So we want to do something new, something that fuses art and architecture in some way. So this is the simplest form you can do. But you can do it in social housing, no problem. It's not a matter of budget, it's a matter of where do you want to go. And if you ask how would you want to live, well, it's more like this. No? You have a villa park. You have houses, you have ample green space, you can do what the space what you want. You can have it as a park, or you can grow food. This is in Hungary, and the red spot there is our house. And many people do this. They grow their food, they exchange things with each other. This is community feeling in villages and in communities like this. So this would be a solution for a housing problem in Holland. This is one of my early projects, the creation of a new polder, where I said, okay, we have a lot of houses here, a lot of plots here, XY, and a lot of high-rise here. And it takes up the same space as agriculture. Not in the proportional values as we have now, but actually equal. And a lot of nature and a lot of world-like, wildlife basically. Certain areas for specific crops, not crops, but specific nature, dunes, etc. And I learned from Bernard Tschumi this idea of the grid, and to impose a grid on it to create unexpected events in that land, unexpected combinations. You could do the same vertically. This is James Wine's stacked villas. Not exactly practical, I think, but it turns out that many designs, like this design of Jean Nouvel in Cyprus, are doing it in a quite smart way. So you need big terraces, very big space. So don't count square meters, it needs to be a garden, and then you can stack them. Talking about green, what if we said, if we consume something, like a fair deal, we must also produce something. Since Marshall McLuhan, we know that we are more and more becoming prosumers, not only consuming, also producing. So what if we apply that to food production? We could do farming at the household scale, and this actually happens. People who can afford it, I have to say, they buy this cultivator to grow vegetables, to grow herbs. Well, this is very small scale. You can do it much larger scale in your household as well. A bigger scale is if you grow food for a restaurant. This is in Holland. Friends of ours, CPZ, they built this this design that is dry assembled, can be reconfigured, is circular, as they say right now, and they grow the food that actually is served in the restaurant. No problem. You need some space, but we have space. A design I made together with Ashok Balotra. You see the name there. He recently died, unfortunately, urban designer from India, but working in the Netherlands. We call this project City Fruitful. So 1,500 inhabitants and providing for food, not only for themselves, but also for exchange with other cities like this. So it's not an isolated thing I'm talking about, it's a network thing. I'm not talking about autonomous, being alone, producing your energy just for yourself and the world is not important. No, I'm talking about a network. So you can grow things that elsewhere are not grown and you can exchange, etc. Or put it on the market, a nearby market. Preferably, we have this, vertical farming. Everyone knows about vertical farming. It's important to know that the yield of vertical farming is at least 10 times traditional agriculture. So if you combine this with the production of energy and the production of water that you need for growing vegetables, growing food, if you make the right combination, you need only 10% of the land. So we have a lot of space. That's basically the message. Don't think we have a shortage of it, not at all. So energy production, yes, why not? Why should not everyone or every firm, every factory be obliged to produce energy? It can be done, it's not difficult. It only doesn't happen because there are other priorities that govern their business. But it could be a simple rule that would create this kind of diversity and this kind of efficiency. Passive, active, networked, all those skills must be active somehow. Household skill, community, neighborhood, city. And it guarantees energy security. So who can be against it? Any scale. So this was in Cambodia, in Angkor. Well, he needed a mobile telephone all day because he has nothing to do basically, so he's looking at his mobile phone. He needs energy, so I bring energy, no problem. We can do it, any scale. Tesla can do it, and you pay quite a high price for that. But why not? We have all those roofs, so why not? Then this is one of my later projects, and I hesitate to say this is a missed opportunity. I mean, why wouldn't we have done a solar roof here? It's perfect. So there are a lot of missed opportunities when it comes to building new structure. Someone has to say, you just have to do it. And if everyone is doing it, no one will complain. And it won't be a money problem. Ashok Balotra, the same urban designer, did it. He designed this neighborhood in Holland. So I have a lot of images from Holland. I could have other examples as well, I think, but in Holland, sometimes we are a bit more advanced. There's a lot of negative rumor about that Europe is not competing with US and China, but at some aspects we are doing well. This is already 2007. So he built a neighborhood, 1,500 houses again, fully equipped with solar panels, and it produces all the energy they need. So why not? It's that simple. Tell your client. But the client will say, okay, but others don't do it. So, okay, it doesn't work that way. So you need the government to rule that, to have that simple rule. I'm talking a lot about IT, that you have to use technology and internet and robots, and it creates the need for a lot of data. So why don't we ask the data center to provide in their own energy? wouldn't they have the money? I think they would have the money. But when the government is not saying anything, nothing happens. So step by step we are getting there. This is in California, where you have a very large solar plant, and this one would be big enough to provide energy for the data center. So you have to realize that if you build a data center, you need at least 20 times the surface area, the roof area, if it's a flat thing, of that data center for solar panels. And you need to do that in relation with thermal energy storage for the buffering of the energy, because it's not only generating energy, it's also storing the energy. In Qatar, we did a little study. It was a competition that we lost. I only show this image. So what if you have an abandoned building and you want to have it producing its own energy, water and food? You would need some extensions. You would simply need that. Or you could clad the whole building in solar glass, of course, but you would need that as a volume, that as an urban farming thing to feed the people that work there. And you need to harvest water, which may be the most difficult part, because if you do it in the analog, natural way, you need quite a lot of space, but you can also do it in the technological way. But then you need solar power to generate to feed the machines. And is that a strange idea? I don't think so. If we are looking into the situation this is Tokyo, I think. Just look at the buildings. Only this is building, and that is the topping up the building. So there are a lot of things up there that could be used in a different way. It could be used for solar energy, food production, smart Kas on the rooftop, water harvesting, easily. And you can combine it with commercials, of course. Why not? You can, if it brings return of investment, you can make any combination. But not only this. From Thailand, from Bangkok, this Plan B building, which is quite outspoken, and I appreciate quite a lot the way they do the advertising by sort of fusing it with the architecture, with the size of the panels. Mostly it's just glued on top of the building head onto the facade. Here it's integrated. So that's one thing that is good. The other thing is, okay, it's return of investment by commercials, but you can have other forms of return of investment as well. Water, it's more problematic, I would say, but it's the same story. Everything that consumes should actually produce something. In the small scale, in the desert, condensation nets, using some technology, like in the desert, solar powered, and producing enough water to live, or use algae for desalination plants on the larger scale. It comes down to, this is a sketch I made for a research project in Doha. It comes down to that you add another dimension to a building. You could call this the fourth dimension, because time isn't. The whole idea of dimensions is questionable, by the way, but that's another story. Another dimension, which is the FEW dimension, the food, energy, water. The nexus, as they say. We are talking about societal effects of rules. I think another simple rule could be this. Okay, let's think of shared responsibility. You can do some of it yourself, but not too much. You need larger structures to do that for you, like communities or buildings, and you need cities and states to do another part. To get there, you need to decentralize production food, energy, water, you need to be networked. You need to network in a bidirectional way, collective and individual efforts. Okay, let's look at another component for society that is potentially beneficial. I'm talking about self-driving cars, Internet of People and Things, where everyone that has an ID, and everyone must have an ID, otherwise you cannot get your basic income, that everyone talks to everyone, everyone talks to everything, and everything talks to everything. In other words, everything is connected. You are connected with the chair, somehow, because the chair talks to you and to the water bottle up there. So everything has some form of ID is labeled, and this is not a fantasy, but actually what is taking place. But how do we take advantage of this? That is more the question. How do we make it that connectivity of everything and everyone, how do we make that beneficial for society? Well, this is how it may look like. This is the limousine the Chinese patient was talking about. So I already showed the villas, this is the limousine. Fashion is another thing. If we think about clothes as of wool, I don't show that here, although I have one image that is fashionable. And then there is, the food must be better. We dealt with that already. Okay, what is in the news? In the news, and that is the media bias. This is always in the news. Autonomous car crashing, making you feel bad about autonomous car. This is the reality, but not in the news. The reality is in the US, 35,000 deathly car crashes per year. No one talks about it. They accept it somehow. But if an autonomous car crashes, that is dangerous. So, and this we can easily apply to politics. Just read the newspapers today, what is happening. It's very biased and very much imposing an opinion simply by using the wrong language, the biased language, and showing one thing and not showing the other. I love the tuk-tuks, the e-tuk-tuks especially. I think they are great, really great. Sometimes I have to wait too long when it's rush hour, but I heard they're going to expand from 300 cars to 1,000 cars. So let's hope it will work a bit better. So I had to take the Grab to get here and not the tuk-tuk. Next time I hope it's the tuk-tuk I like. And some of them are crazy guys. So it was raining, and then this guy took us from somewhere near the river to where we live. And then he asked, "What nationality are you?" I said, "We are Dutch." He has this internet radio station up there. And said, "Oh, okay, I have a Dutch news. I have a Dutch news sender for you. The most terrible music." Schlager music, terrible. But funny, and in a way it shows the connectivity. How through internet, through IT and technology we connect. So he easily connects to us as Dutch people. Okay, now let's discuss robotic production. That's closer to ourselves. It relies on machine-to-machine communication, this one. Because everything else, if you use language, if you use communication only between people and people, a lot gets lost in translation. We simply don't understand each other because we have different expectations, we use different words for the same, we have different language. But in machine-to-machine communication, they understand each other. They know exactly if this is the package of data, then the other machine, of course you have to synchronize that. The machine knows exactly what it is. I mean, not just vaguely, but exactly. And this is the main thing. So it's this exactness that will allow for other forms of production, decentralized, on command. You need parametric design, scripting. Well, I showed you that. One of our things is to control this, and that is the minimalist part of our job, actually, how we look at things. One building, one detail. If we can describe a whole building just by one component that is parametric, but has this huge variety of appearances and performances, it's very cost effective, and it still creates that much desired variability, the diversity. We can call it back. We can call it fire to factory manufacturing. It's always dry assembly, so you can reuse it, circular, or maybe even spiral if you wish. But we don't use concrete. So this is, of course, the main thing. What if we don't use concrete at all? If you look around you in Bangkok, 99% is concrete. So this is quite a shift in attitude. But we could do it, because concrete, I'm saying no concrete, because this is the most polluting part of the building industry. By working like this, you don't need molds, so you build only once. Usually, when using molds, you build twice. First you build the mold, then you cast in the mold, so you build twice. Not necessary if you use the above way of working. And we don't need scaffolding. I showed that in an example. You just put one component next to the other, you bolt it together, and you're building self-builds. Very efficient and very cost-effective. It's hard to be totally radical for a building, but we can come a long way. I don't think I can manipulate the sound here. Okay, this is 3D printing. Now we are talking art. So we're not only talking architecture or other fields of knowledge, we're also talking art. This is a project by Ilona. Here we have the Victory Boogie Woogie. It was unfinished, so that justifies to actually look into that again. She was looking at the colors, and each color got a different depth. And then we 3D printed it in a way that every single part, call it component, we had this zigzag path for the printer so that it would naturally grow together, so it becomes one part, one consistent part. That worked. On the larger scale, we did this at Hyperbody. We called it proto-cell. We wanted to have a component that has it all. It has the insulation. Well, we think of insulation in Holland. You don't in Thailand. I mean, somehow everything is single glazing, no insulation. I don't understand why, but I can understand it from the history of building, that I can, but not when considering cooling and other needs we might have. One component that does it all. It is a window. It may contain some equipment to control the climate. It is wired, right? So you can run all the wires. Suppose that you need wires and not wireless. Everything combined in one component, structurally, aesthetically, fault lines, aesthetically integrated into one component, one building, one detail. That is the idea. And it's not boring. I mean, it is diverse, it somehow feeds the senses in the same way as nature does, I think. Nature also has simple rules, all the leaves of the tree are seemingly the same, but they're all different. It's a bit like that. Simple rules that create diversity. And here we used it for light effects and projection of content here in this part. And we had an interactive part that some parts would actually come up if there was a speaker and would function as a lector. Same process for many of the buildings we did after 2000, after we finished the water pavilion, where we actually learned how to do that, where we found this way of working, like this exhibition project, Web of North Holland, looking from the inside to the outside, having this, as Corbusier might call this, the magnificent play of light and shadow. It was really nice to be in there. So it's transparent summer pavilion. Later we redesigned it, so repurposed it, reused it, took it apart, built it up again to function as our laboratory at TU Delft, the iWeb, we called it then. Still the web, because it's web-based and it has this swarm-like web of components. 2007, then there was a tragedy, I don't show you that. The faculty burned down completely, and also our lab was no longer in use because it was cut off from the infrastructure. Inside of the lab we had this space inside, which is a working space and an arena, interactive arena, sensors connected here, projection screens that could be inverted to work either at this part or in the middle part. When you have a group session, you would work here. When you would have to work out something, you would work here in separate groups. So it's a pentagon. You could have 5 groups working simultaneously and then come together in the arena, which is the same concept as we had for transports installation at the Biennale in 2000. Similar technology for larger buildings. This one we realized in Budapest, Cultural Center. And the whole new structure is exactly obeying the same simple rules as we did with the cockpit. The client went to see the cockpit and wanted to have something like that, so that happens. I want more of the same, but then it's not the same, it's completely different. For the existing part, we also developed parametric details, because each brick is different, meaning that each window opening was different. So we had to parameterize it actually to streamline the process. So even retrofitting, re-engineering, or reverse engineering, you could say, the existing buildings is also very helpful. So parametric design is very powerful. Their interior, we provided for some larger spaces for multiple usage. That worked very well. It was also used, this building, for the movie The Martian, so I can recommend you to look at that movie again, probably, and then see that NASA headquarters was actually located inside this building. Later projects in Abu Dhabi, just to reveal the structure, steel structure, all individually different components. I mean, this is, they did actually X parts as one component and then connected 2 triangles as one, actually fused components of 2 triangles to fix to the structure. The way we organized this process, because we were not there, we were working from the Netherlands, we gave them a guidebook, a procedural guidebook, what they have to do step by step, how all the components relate to each other, parametrically. And one of the things that you should notice is that there's no corner. So the detail in the corner is the same as here, only different parameters, which is quite exceptional. The procedure, the rules are the same all over. And it's mapped on that three-dimensional model, of course, so that is ruling as well, and the curves are ruling here. But not having a corner is absolutely efficient, because you don't need an extra detail, it's the same detail. So this led us to say that Mies is too much, too many details. And knowing Mies van der Rohe, it's, can you be more simple? Yes, this is more simple. A project we did for Qatar, it's a proposal, but still somehow in a slow process and consideration. Here you see it from in between two Foster towers, how it would be positioned there on an artificial pier here in the bay. And it would have an underground entrance, and you would go from sphere to sphere. The design is based on a constellation of Ursa Major. It's a star sign. Some are bigger because they shine brighter. Some are farther down into the universe, and then they have a different three-dimensional position, and together they form this sign. And in Doha there's a tale, a fairy tale, a historical one that's called the Seven Daughters, that relates to this sign, to this constellation. It's a double hexagonal structure. What you don't see here is that they are connected. I mean, it was a very quick model in that sense. But here you are inside the sphere, and here you go from one sphere to another using sort of pods. Robotic production. Ideally, it's local. So you don't use a robot the other side of the world to produce for here. You would like to have a robot working for you here. So we have these as an ID. So we fold out the container, that becomes the workplace. You produce the component, you bring the components together, and that's it. So it looks almost like not doable, but we know from our practice that we can do this. There are some things you should know, of course, that the material is not exactly proper yet to do this, because you need reinforcement in the concrete mix. You need to have glass fibers or carbon fibers or other stuff that makes it strong, and you need to design the connections, which is the biggest challenge of all. To design the connections, not only the component itself, but how do they connect. So you're talking about connectivity again. So how do you connect things? How does the bird in the swarm connect to the other bird? A radical version of that one building, one detail is this proposal for Dubai Expo 2020. We were almost there, but we just missed the selection. We had 3 paths interweaving into each other: a water path, a food path, an energy path, so the FEW again. And you could follow one path, but you could also step aside and then decide to follow another path. You see steps and you see slopes. The idea was to have the slopes for small automated golf cars, say, to transport the people that are not so good at walking, and you had the steps for most other people. All over the whole project, one building, one detail, because every triangle you see is a component with a different performance in perforation, in porosity, different performance in strength, thickness of the steel, all is calculated by a company in Holland called Central Industries Group, who are also responsible for a lot of advanced projects by Zaha Hadid, for example. So this company is very good. It's a company that produces components for the shipbuilding industry. So this is the way to go. Forget contractors. Go to manufacturers directly, either wood or steel or glass or whatever. Go directly to them and make sure that the project is predominantly their product, then they will adopt the project. So not a variety of 10 different components, then they will think, oh, I'm only one of them, but if they are the main one, they will act as the main contractor and you don't need a contractor anymore. This I wanted to show to illustrate that artists were actually looking into possible societies when robotization would take command. So this is Constant, a Dutch artist who made a series of projects called New Babylon. He started in '58 and worked 10 years on this project. The idea is production is robotized, people are free. They can go wherever they want to go. So they become the new nomads, new international nomads. They go from place to place, and the place will change all the time because people are doing things. Even if they are not working, they will do things. That's my belief also. If you are not earning your money, like working for another one, if you get your money, you will still do things. And probably even more so than working 8 hours a day for someone you are not really interested in. And okay, Constant believed this, Martin Luther King believed this, Bertrand Russell believed this, and I think many people believe it, but they always have this idea of, okay, but then we will have inflation. Because people have money and they didn't earn it, so we will have inflation. People have more money, prices will rise, and then you will have the same situation again, that they actually have a lack of money. But there are many other people that say, no, this is not the case, and there are experiments, many experiments actually, that actually show that it's not the case, and people actually become more active. Home delivery is just something that I feel as very comfortable, but it should be considered together with other things like produce locally, on demand. You can minimize packaging because you don't need to pack everything because it's delivered in a much more organized way. You should avoid large-scale storage facilities, which combines with local production. It's automated. You have these traveling agent algorithms, and that leads to, if you calculate, if you compare all the individual movements of cars and people or public transport, anything, to shopping centers and back, and you compare it with delivery, home delivery, it's much less kilometers made because it's much more efficient combining the delivery of people that are living not so far from each other. More and more you will see this on the road. This is in China. Ongoing experiments. It works. It raises a lot of questions. How do you pack your stuff? For example, is it still wrapped in plastic? Maybe we should rethink that. And that is about waste. And I think that can be addressed by something like this. If you produce waste, you have responsibility to take it back. So if you have a refrigerator and you pack it in a lot of plastic and cardboard, you have to take it back. Now it's the responsibility of the consumer, and we have stacks of that. If we buy something, we produce a lot of waste, not because we produce it, because it's given to us. by packaging. Politics try to make people responsible for this, but they are not. It's the companies, the transport, the whole system of central storages and non-local production that is responsible for this. We can do differently, I think. Closer. A few days ago we were in Hua Hin. The sea is dirty. Really, it's dirty. There's a lot of plastic on the beach. And I think some of this is cleaned up after daytime, but not sure, because next day we didn't see it. But if you look into oceans, I mean, there's so much of this. And then guys like this make you feel almost personally responsible for this, which you are not. Because there's no other way. If I buy some fruit or anything, it's always wrapped. Because it has to live for quite a time, and by wrapping it and packaging it, it can do that. But if you have more local production and you have this shared responsibility for food, energy, water production, it can be different. Step by step it can be different, and in my belief it works only if you use technology for this. Not if you go back to earlier days, how people would do it, but if you use technology for this, for the good. So I'm talking about a techno-social way of approaching this instead of a techno-feudal way, which is dominant right now. Oh, here we have fashion. So this is Melissa. We stumbled upon this shoe shop, Paragon, I think. Victor and Rolf are famous Dutch designers. They came from a school like this, like INTA. They become famous as design icons in Paris. And they designed this of recyclable plastic. So now you see it coming to the bigger firms, to the fashion industry. Well, you all know that it's coming. And they are proud of doing their thing, maybe not so proud of this, made in Brazil. And they combine it with, I think there's something like vegan. It says we are vegan. So they combine it with not eating meat, not even fish. So they have all the good intentions, but of course it's PR. But it shows that it's coming. So I'm not talking about anything that is not here today. I'm talking about the here and now. And these are some of the developments you see happening. Another thing you see happening, that there's an app for everything. And I think that's a good thing. It's so much more comfortable than it was in earlier days, that you got to go to a travel agent or anything. Everything you can do online, but it creates a lot of data. So don't forget to combine this, the comfort, with the need for producing energy when you use this. So it's not the responsibility of the consumer, which actually is used by the big tech companies, but it's the responsibility of those companies. You can rent everything. So maybe this is a good thing, that renting everything, house, cars, whatever, equipment, becomes a form of shared ownership. As they say, sharing is the new having. And if you find a good business model for that, which is spending and income in a streaming real-time fashion, that could work. And I think it could be very beneficial. We developed an ID we called MANIC, multimodal accommodations for the nomadic international citizen in Qatar. And I had an early ID before, which I called the pop-up house. It's basically an empty space with a deep floor and a deep wall, which can convert the space into anything, into a bedroom, into a kitchen of 50 square meters. There are examples I have seen with some Chinese architect who is actually doing almost this in a bit more inhibited, restricted fashion, but the multimodality, the customizability of a space, I think, has a big future, especially in dense metropolitan areas where you basically have a 50 square meter apartment, but it has this single use, like one bedroom and kitchen there. So this could be much more interesting as a space to live in if we can program it, if we can use technology to use it as a social space with much larger dimensions. Then this is my last rule, but I have no knowledge about this at all. I only have some ideas. And of course, AI will play a major role here, as it might play that role in architecture in the near future, already in the now. It's about real time. It's about connecting everyone to everyone and everything, etc., in real time. Meaning that everything is streaming. So if I have income, that's the idea here. If I have income, it doesn't come in one batch, it comes in gradually, minute by minute or second by second. So I see some bar moving, money coming in. If I would spend money, there would be another one, money going out. So if you would spend by fashion or whatever, you would not pay the whole amount in one, no. You would pay gradually. So everything would be streaming, gradually coming in, gradually. So it would be very easy to see a balance as an individual, to see balance as a company, to look at the balance as a state, and adjust in real time. Now we adjust every so and so many years, we have a new rule. If you have everything streaming, it's a different story. If you use IT in the proper way, I mean, not in the dominance way, but in the way of facilitating a fair and just world, that's maybe my naivete, but I sincerely believe in that, then it could be much easier, and you would actually avoid getting broke, you would avoid spending too much, because there would be a warning sign. Like we have in our programs, if we do scripting, we always have a warning sign. The dimension is too large, the angle is not good, which is one of the things you can build into scripting. So it's the same. It's the same about other things in society. So this is not my expertise, so I'm totally naive here, but I think it would apply to many other fields of science and technology. This one should run. If it doesn't, I make it run. We call this interactive wall. What it does, it responds to movements of people. So imagine a wall piece of any building, any chair, anything, to be smart in some way, to respond to your own movements or maybe even explicit commands. But here we use sensors in the base that knows if there's someone there, and then we pre-programmed, in this case, what it should do. We used Festo technology. Festo is a very interesting company making muscles. So inside, interior in this structure, we have muscles that can contract. If it contracts, the whole shape of that wall piece changes its shape. This movie is made by Festo. That made us think of some possible applications, and we have done quite a few projects as acoustic barriers. So why not have an acoustic barrier that is only there if you make noise? Why would you have a wall if there's no train that makes the noise? It doesn't make sense. So we programmed it in such a way that depending on the proximity of the train, it sends a signal, communication, to the components that one by one would act and curl up to form that acoustic barrier, and then relax again when the train has passed. And maybe it would want to move by itself as an act of elegance. Who knows? It could actually have a will of its own at a certain moment. So this is a condition we were looking at for architecture. Architecture could become proactive, that it proposes situations where we would respond to, which is one step beyond interactive, where you would actually do something first and then it would respond to your actions. Now they can act. Another example we did for South Korea called the Digital Pavilion. This is an internal structure that is based on electronic cylinders, pistons, that can change their length, so they take compression and tension, which is different from the muscles of Festo. They only take tension. And the idea was that by moving in that space, you could open up a space that otherwise is closed. You approach it, and then that environment responds. This is a movie that one of my PhD candidates made on my request to show that this approach to architecture is inclusive. Many people talk about inclusiveness, but what does it actually mean? In terms of geometry, for me it means that non-standard architecture, because that's the term we use for it, non-standard architecture includes all forms of traditional architecture. While at the other hand, if you start from Platonic volumes, start from cubes and these Platonic volumes, it excludes all forms of complexity. So here you see we use exactly the same algorithm, but only move the points to certain positions that it is a cubical thing. It's the same thing. It's the same algorithm. Only reference points are placed differently. To me, this says it all. That we can create a diversity that is inclusive and manageable and cost-effective. So if we have all these rules I was discussing, and we make strange combinations that you have not seen before, we might get somewhere. We might get to a situation that is more preferable, more likable, better, fair society. If you ask ChatGPT, it says this. Interestingly enough, it's very politically correct, but it's also very generic. It doesn't say anything, basically. It basically says, be a good boy, and then you'll get there. No, you have to be more specific. We have to really be specific in how we will reach that goal. And that goal, that's the open question. It's still open for me, like was open for Varoufakis. Is that utopia, or will it lead to a dystopia? Or in other words, this is another now where we find ourselves in. It's Ratchaturi BTS. I like it. Even if it rains, or especially when it rains. Okay, thank you.
Thanks very much, Kas. Obviously, very difficult to think of society as something that you can just apply design to. So, a really masterful survey of both the general ideas behind the architecture and the parallels with societal patterns at all sorts of scales. So, fantastic. Thank you very much. We are over time, but if we do have a quick question, is anybody interested in joining in? Okay, perhaps, yes. The room doesn't do that.
Yeah, and thank you for the opportunity to ask questions. My name is Michael, and I really appreciate the slides presentation. It was really nice, and I think it has opened me up to a whole lot of things I really know. And my question is, considering the rules that have been shared, have you considered any form of scenario that would disrupt these possible predictions? And what are some of the things that can possibly disrupt or bring about disruption, basically, on achieving these rules or enjoying these rules? Thank you.
Well, I think it basically disrupted all the time by almost every big tech company, because they typically don't want this. They only use it, all these elements that I have showed, in their greenwashing, but they don't do it. So there's this hypocrisy between what they are saying and what they are doing. So you have to look at what they are doing. So typically they're obstructing it, yes. But like with, I'm not a revolutionary, but it is, when it becomes too much, the people will start revolting somehow and take it in their own hands. So that's one way to go. Just do your thing, basically, and hopefully keep believing in it and use technology. That's the other thing. So don't accept that they use technology over you, that you actually work for them, because that's what's happening. But make technology work for you somehow and for your immediate society. So answering your question, I think yes, they are abstracting all the time. But that's normal, isn't it?
All right, thank you, Kas. Thank you, Michael. I think we'll call it to a close there. I'm sure Kas would be happy to answer questions if you want to come up and say hello. The next lecture in the series is 3 weeks from now, November 15. Dr. Pon Tam Pirimon. I think that's right. You're welcome to come back and join the next lecture. That will be about landscape architecture and conservation. For this evening, there should be a food box of some sort out by reception, and if you could please scan the QR code, and there will be a satisfaction survey. So thanks again to Kas for coming to Bangkok and for the wonderful lecture tonight.
Thank you.
Thanks to the Dean and the faculty for sponsoring this event. Thanks everybody for coming. I hope you had a good night. Good night.